Today I will discuss the topic that is the valence shell electron pair repulsion theory. It is also known as a VSEPR theory. This is the topic. Valence shell electron pair repulsion theory. Actually, by taking the example like NH3, there are 5 electrons in the valence shell of the central atom. Nitrogen is the central atom, okay, and it is combined with the 3 hydrogen atoms according to the Lewis dot structure, okay. So usually VSEPR theory is proposed by the scientists Sedgwick and Powell in 1940. Simply they explain about the shape of the molecule or geometry of the molecule, which is based on the electron pair present in the outermost shell of the central atom in bonding state. Okay, for example, NH3. In NH3, nitrogen is the central atom and hydrogens are the surrounding atoms. There are 1, 2 and 3. These are the bond pair or bonding electrons. 1, 2 and 3, these are the bond pairs or bonding electrons, and this is the non-bonding electron, that is the lone pair electron or non-bonding electron. Bonding electron means the electron which take part in the bond formation is known as bonding electron, and the lone pair electron, that is a non-bonding electron which is present in the outermost shell or valence shell of the central atom, that is the lone pair or non-bonding electron. And there are main postulates of the valence bond theory. The first postulate is shape of the molecules depends on the number of electron pairs around the central atom. That is the first postulate. The shape of the molecules depends on number of electron pairs around the central atom. It means in case of suppose NH3, there are 1, 2, 3, 4 electron pair. How many electrons pair? 4 electrons pairs. Okay. How many electrons pairs? 4 electron pair. Suppose in case of BCl2, beryllium is the central atom, Cl, Cl, these are the surrounding atoms, and the electron pairs are 2. Okay, it means first postulate is the shape of the molecules which depends on the number of valence shell electron, okay, of the central atom. And the second postulate is pair of electrons in the valence shell repel to each other. Why they repel to each other? Because of they are negatively charged. It means electron clouds. Either they are the bond pair or lone pair. They repel to each other. Okay, and the third postulate is these electron pairs tends to occupy such position in a space that minimize repulsion and maximize the distance between them. This is an important postulate of VSEPR theory. It means if there are suppose two pair of electrons are present, 2 pairs of electrons are present, then in which condition they have the minimum repulsion and maximum distance. If these 2 pairs are located at linearly or 180 degree, it means if there are 2 lone pairs or electrons, 2 pair of electrons are present then these two pair of electrons present at diagonal to each other at 180 degree. At this condition, there is a minimum repulsion and maximum distance. Similarly, if suppose three pair of electrons are present, so suppose B is the central atom, then it is simply possible if these three pair of electrons are present at a trigonal place with 120 bond angle. It means if the two pair of electrons are present, then the shape of the molecule or geometry of the molecule is linear, and three pair of electrons are present, then it is the trigonal planar, and four pair of electrons are present, then there is a tetrahedral. It means this is the important point. And next, a multiple bond is treated as a single electron pair. Multiple bond is treated as single electron pair. Suppose carbon dioxide, CO2, and the structure of the carbon dioxide is C double bond O, double bond O. Means there is a double bond between C and O. This is treated as a single pair, okay, as a single pair. And here double bond, this is treated as a single pair. It means the total number of pairs are 2. So this is also an important point. A multiple bond is treated as a single electron pair. Either it is double bond or it is the triple bond. Okay, for example, carbon dioxide, there is a double bond between C and O. It means this double bond is treated as a single electron pair, and this also treated as a single electron pair, and total electron pair is 2. And according to this concept, that is the electron pair occupies such a position in a space that minimize the repulsion and maximize the distance. It means if there are two pair of electrons are present, then the geometrical arrangement is linear. Therefore, carbon dioxide is linear. And the last important point is the repulsive interaction of electron pairs decreases in the order. That is, there is a maximum repulsion between the lone pair, then lone pair, bond pair, and then bond pair. It means maximum repulsion between the lone pair, then lone pair, bond pair, and then bond pair. For example, in case of NH3, there is a one lone pair and three bond pair. And this one lone pair electron present in a p orbital. This type of repulsion, that is the lone pair bond pair repulsion. And here again, there is a lone pair bond pair repulsion. But here, there is a bond pair repulsion. And here, bond pair repulsion. It means in case of NH3, if the repulsion between the lone pair and bond pair, then it is the lone pair bond pair repulsion. If there is a repulsion between the bond pair, then it is known as bond pair repulsion. And take one more example, that is the H2O. In case of H2O, oxygen is the central atom, and there are two pair of electron. First pair of electron, second pair of electron, and two bond pair. It means, according to the last point, that is the repulsive interaction of the electron pair decreases in order of, there is a maximum repulsion. It means between the lone pair, there is a maximum repulsion between the lone pair. Then the repulsion between lone pair and bond pair, and the minimum repulsion between bond pair and bond pair. So these are the main postulates of the VSEPR theory, and with the help of VSEPR theory, we can predict the shape or geometry of the molecules, which is based on the number of electron pairs present in the outermost shell of the central atom in any compound. Okay, class? Geometry of the molecules which contain only bond pair electrons. There is no lone pair electron. First case, if the number of electron pairs are 2, then according to VSEPR theory, there is a linear geometry and 180-degree bond angle. And the possible compound is AB2 type, means, for example, BeCl2, and there are 2 bond pair. It means the geometry of the compound is linear and bond angle is 2. Next, if there is a 3 electron pairs, then the arrangement of the electrons is trigonal planar. Means in trigonal planar, there is a minimum repulsion and maximum distance. And the bond angle is 120 degree. And the possible compound is A, B, 3 type compounds like BF3. That is the possible compound. And next, if there are 4 electron pairs, then the possible geometry is tetrahedral and the bond angle is 109.5 degree, and the possible example is AB4, for example CH4, CCl4, NH4 plus. These are the examples which contain the 4 electron pair, and the possible geometry is tetrahedral with bond angle 109.5 degree. And the next case is 5 electron pairs. It means the arrangement of the electron pairs is trigonal bipyramidal. Trigonal bipyramidal. It means there are 2 different types of bond angle, 120 degree and 90 degree. In this case, the bond present above the plane and below the plane. These bonds are known as axial bond. Okay? It means there are 2 axial bonds with 90 degree bond angle, and there are 3 equatorial bonds. There are 3 equatorial bonds with 120 bond angle. Okay, so it means if a 5 pair of electrons are present, then the arrangement of the electrons in a trigonal bipyramidal geometry, there are 2 types of bond angle, 90 degree and 120, and the possible compound is AB5 types compound like PCl5. And the best example for 5 pair of electron is PCl5. It means as a central atom phosphorus, there are 5 Cl atoms are attached at these places, and there are 2 axial bonds and 3 equatorial bonds. Axial bonds, especially because of the 90 degree bond angle, there is a less bond angle as compared to the 120. There is a maximum repulsion. Therefore, this bond length is comparatively longer as well as weaker than the equatorial bond. That is the important question. Why axial bonds are longer? Because of the less bond angle and maximum repulsion. And the equatorial bonds are comparatively shorter and stronger in nature. And next case, that is if the number of electron pairs are 6, then the arrangement of the electron is octahedral and the bond angle is 90 degree, and the possible compound is AB6 type compound, and for examples SF6. Okay, so these are the common examples. If there are 2 pair of electron, it means AB2 type compound. 3 pair of electron means AB3 type. 4 pair of electron, AB4 types. 5 pairs of electron, AB5 types. And 6 pair of electron, AB6 type. And the common examples, AB2 type like BeCl2, BeF2. And AB3, BF3. AB4 type like CH4, CCl4, NH4 positive, and AB5, PCl5, and AB6, SF6. These examples only contain bond pair electron, no lone pair electron. If there is a lone pair electrons are present, then their shape of the molecule as well as bond angle will be changed from their normal bond angle. These are the normal bond angles. Okay. For example, suppose in case of a 3 pair of electrons, if there is a 2 bond pair and 1 lone pair electron. So A is the central atom, and there are 2 pair of electrons, 2 bond pair and 1 lone pair. Exactly अगर आप देखें in case of examples के through, like sulfur dioxide, okay, sulfur dioxide containing 1 lone pair electron and 2 bond pair electron. According to the VSEPR theory, there is a repulsion between a lone pair bond pair. As a result, this bond angle decreases from 120. It means this bond angle is less than 120. And the shape of the molecule is vent shape or angular. It means the shape of the sulfur dioxide molecule is vent or angular. Similarly, in case of AB4 type compounds, if they contain number of bond pair 3 and lone pair 1. For example, NH3, nitrogen is the central atom, and there are 3 bond pair and 1 lone pair. Okay, and this is the lone pair bond pair repulsion, and there is a bond pair repulsion, and due to the dominating lone pair bond pair repulsion, this bond angle decreases from the normal bond angle, and this is nearly 107 degree. It means the bond angle in case of ammonia is less than 109.5 because of the presence of 1 lone pair electron, and which causes the repulsion, that is the lone pair bond pair repulsion. Next example, if they contain bond pair, number of bond pair 2 and lone pair 2. For example, H2O, the central atom is oxygen and there are 2 lone pair and 2 bond pair. And there is a maximum repulsion between lone pair, then lone pair, bond pair. Okay. As a result, first thing, their bond angle decreases from the normal bond angle and it is nearly 104.5 degree, and the shape of the molecule is V shape, or it may be a vent shape or angular shape. It means due to the presence of lone pair electron, their geometry or regular geometry changes. Like in case of NH3, it is the pyramidal shape. In case of H2O, it is the V shape. And next example is, in case of, especially अगर आप देखें, in case of AB5 type, if there is a 4 bond pair and 1 lone pair, okay, and suppose A is the central atom, and according to the normal geometry, it is trigonal planar, but there is a 1 lone pair and 4 pairs of electron, and the geometry of the molecule will be seesaw, because 1 lone pair electron occupy here and there is a bond pair surrounding atoms. So if 4 pair of electrons and 1 lone pair electron, the geometry of the shape of the molecule will be seesaw. And for example, exactly SF4, it means the central atom is sulfur and surrounding atoms are fluorine, F, 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 and there is a 1 lone pair electron, and this is the structure of SF4, and this structure or geometry shape is especially a seesaw shape. Next, in this case, if there are 3 bond pair and 2 lone pair electrons, 3 bond pairs and 2 lone pair electrons. Exactly, अगर आप देखें, it is trigonal planar. If there is only bond pair electrons are present, no lone pair. But if there is a 2 lone pair electron, it means a lone pair electrons occupy such a place where there is a maximum angle, that is 120 degree. It means these 2 lone pair electrons are occupied at these places and the bond pairs are at these places. So simply the shape of the molecule is T-shaped or vent T-shaped. T-shaped or vent T-shaped. For example, ClF3. So Cl is the central atom and 2 lone pair electrons are occupied at the 2 equatorial places with 120 bond angle. There is a maximum bond angle, and the 3 bond pairs are at, one is above the plane, another is below the plane, and third one is at the equatorial place. And this is a T-shaped or vent T-shaped geometry. So it means if the lone pair electrons are present, then there is a change in shape of the molecule as well as change in their bond angle. Okay, class.